In the last video, sorry about that. In the last video, we looked at an example of how to plot the right ascension data from our lab work where we're trying to find the center of the Milky Way. By the way, let's give credit right now to Dr. Robin Ciardulu, if I'm pronouncing that correctly, from Penn State University, who compiled all of this together for this lab. All right, so the right ascensions, again, the only one that you probably can't plot is if you look at PAL 2, it has a right ascension of 4 hours, 46 minutes. And so you say, well, it's in between 4 and 5, but it's 35 kiloparsecs away. So it's like way off the charts over here. And so you can kind of make a note of that or just ignore it. We should be able to plot every single object besides that one, which is just sort of off the charts. Everything else will fit on this plot. For declination, you've got positive and negative declinations. And because they've divided it only like 45/90, you could further divide it by -15, -30, -45, -60, -75, -90. So it goes up by 15. Likewise, +15, +30, +45, +60, +75, +90. So again, this is just if we're pointing a telescope, how far up or down, that's one of the axes on a telescope. In order to plot the first object, 47 Tucanae, and its declination, -72 degrees, 2 arc minutes, if this is -75, the -72 will be sort of just before it, sort of along this line right here. And we still use the same rule for how far away is it from the center. So this is the center of the galaxy. 47 Tucanae is 4.6. 47 Tucanae is 4.6 kiloparsecs away. Like it still is at that distance. And so we count out 1, 2, 3, 4.6. And so that would be the declination coordinate for 47 Tucanae. Note that there's only 1, 2, 3, 4. Okay, 4 objects with positive declination, and one of them is that outlier. So really on this graph, you'll only have 3 points that are above 0 here. Be mindful of the positive and negative sign. By the time this is done, there's going to be a bunch of dots, mostly down here, a few up here. And there's going to be a bunch of dots on your right ascension graph, right? And you need to use your judgment as to where the average position is for all those dots. Can I have a volunteer who's completed their lab work bring me their right ascension and their declination graph? Any volunteers out there who's already completed that in class? I think we have a few students that have done that. I want to show you how to report your final answer once you've got sort of that data. So it's clear there. So thank you. So here's an example of some completed lab work, and you can definitely tell that the objects that orbit the center of the Milky Way are not just sort of spread out randomly everywhere. They tend to cluster sort of around here, right? Likewise, the declinations of these objects which orbit the center of the Milky Way are not just anywhere. They tend to be sort of right around here. Now we could calculate the average declination by adding up all of the declinations on this list and dividing by, I think there's 30 objects here. That's a very tedious calculation. What we want to rely on is our judgment to just say, well, they tend to be around here, and I bet you, sort of that seems like a sort of a good fit for the average position. So I might judge somewhere around, -30. So you just simply use your judgment to say where you think the average position is if you don't feel like calculating it, which I would sort of suggest against. And so I might choose a declination of, -30 based on that. I might choose a right ascension of, 18, but maybe there's a few down here. I guess there's a few up there. So, somewhere between, 17 and 18, I'll pick 17. So if I choose based on this data that the average right ascension is 17 degrees, then I'm going to go to on my star chart, I'm going to find 17 hours of right ascension. And I know that the center of the Milky Way is somewhere along that line because the average position of all those objects orbiting is here. Negative 30 degrees is right here, right? So it's tough to sort of see that, but there's 0, negative 10, negative 20. So negative 30 is right here. And so if I draw a line, a horizontal line corresponding to negative 30 degrees of declination, then where those two lines intersect is where I'm judging the center of the Milky Way to be. And so that's what I want to know. I want you to turn in the star chart with your name. I want you to clearly label Sagittarius A star, which is the name of the supermassive black hole at the center of the Milky Way. And please list the right ascension that you chose, in my case, 17 hours, the declination that you decided on, in my case, negative 30 degrees. Okay, and so that's really what I'm looking for full marks on this. Your name, a labeled, clearly sort of labeled position based on what you feel like the average values are for right ascension and declination. So it is somewhat tedious to, plot all these points, but it's not impossible. You can do it in one class period if you work diligently. And then the conclusions are just sort of very forthcoming. Use your best judgment to try to arrive at that solution before you, do some research there. And so here is a screenshot from my phone of my Skyview app from last night when I was doing some stargazing. You can see the moon was in the night sky. So it's about 11 o'clock at night. And there was the constellation Scorpio. And you can see I was looking at what the sky location of our Milky Way galactic center is. And here's the spoiler. Right ascension, 17 hours, 45 minutes, 41 seconds. Declination, negative 30 degrees, 59 arc minutes, 24 arc seconds. And so 17 hours, negative 30 degrees. It's not like I knew that or anything going in, but that is exactly, this is exactly where it's located. That is the position of our Milky Way. And so this lab really does work. It gives you sort of an idea about where the position of Sagittarius A star is located, right around sort of there. Wouldn't you know, it's near the constellation Sagittarius. So Sagittarius is an archer whose arrow points towards the center of the galaxy. There's Scorpio sort of right there. All right, if you have any questions about that, please don't hesitate to leave it down in the comments below, or if you happen to be in class, just call me over and we'll see you next time.